Okay, this video is meant for my geometry students. This is a sections 8.1 through 8.3 quiz review for your quiz coming up on Wednesday. Alright, so let's start with our first problems here. We are going to rewrite the ratios. So we'll do two problems. The first problem, let's say we have 18 inches over, and we'll go 5 feet. Okay? So in these problems, you have different units. So what you must do is convert. And remember, you always go big to small. Okay, because that requires multiplication and it's a lot easier. So I look at feet and inches and I say, okay, 1 foot is 12 inches. So that means 5 feet times 12 by 5 is 60 inches. So this is how I'm going to rewrite my ratio as 18 inches over 60 inches. Now that my units are the same, my units cancel, and now it's just, can I divide? Well, I think that 2 goes into both. I think I can do better. 6 goes into both, right? 6 does. And I'll get 3 over 10. And there's the simplified ratio. That's English units. Now let's do the metric system. Let's do 12 liters over, and let's do 4,800 milliliters. Okay, whatever. So 12 liters over 4,800 milliliters. Well, remember to do conversions in the metric system. There's this kittens hide down under dad's car motor, or however you remember it. This could be a B for the base units, but U is for the units. U is where liters is, M is where milliliters. So here's my liters, here is my milliliters. So I'm going to convert liters to milliliters, and I'm going to move the decimal place 1, 2, 3 places to the right. So my 12 liters, here's my decimal, is going to go 1, 2, 3 places to the right. And it's going to become 12,000 milliliters. So my new ratio, we'll do it down here, is now going to be 12,000 milliliters over 4,800 milliliters. And the milliliters cancel. I can cross off 10, 10, 10, 10, and now it's 120 and 48. Now I don't think it'll go evenly, so again, you're just trying to find the biggest number that goes into both. So it's just a guessing game. And I guessed correctly with 24. Okay, so if I divide both by 24, and again, you can just divide them in your calculator, whatever you want to do, but you need a ratio. When you divide by 24, you get 5 over 2. And there's the simplified ratio. So that's where the units are different. Okay, our next question is going to be a proportion question. Okay, and here is our proportion we're going to do. 5 over 2y minus 7 equals 3 over y minus 3. So we're going to cross. Oh, let me use a better color, blue. We're going to cross, multiply, and I'm going to put these binomials in parentheses, because when you cross multiply, you need to make sure you distribute across that. So we'll just do 5 times y minus 3 equals 3 times 2y minus 7. And we'll distribute 5y minus 15 equals 6y minus 21. Okay, we got to combine the y's. They're on opposite sides of the equal sign. I'm going to move the 5y by subtracting it, because that'll keep my y positive. Those 5 y's cancel. Negative 15 comes down, and this is going to be 1y, or y, minus 21. I'll add 21 to both sides. Negative 15 plus 21 is 6. 6 equals y, and there's my value of y. Now remember, you can always check by plugging it back in. If I plug 6 in for y, I'm going to get 12 minus 7, which is 5. And if I plug 6 back in for y, I'm going to get 3 over 3. And what do these simplify to? 1 and 1. And I'm correct. So you can always plug it in and check. Okay, here are the third problems we'll take a look at. This will be A, and that'll be B. Okay, these are ratios and geometry. The perimeter of a rectangle is 40 feet. The ratio of the width to the length is 2 to 3. Find the length and width. So recall that with a ratio, you can multiply it by any number as long as you do it to both numbers. So we can multiply by a variable in x. Okay, so on my picture, 2x, 2x, 3x, 3x. The perimeter is 40. So all four sides must add up to 40, and that's what I'll do. This left side is 10x equals 40, and divide by 10. And x is 4. So I want the length and width. The perimeter is in 40 feet, so I'll put 2 times 4, which is 8 feet, and 3 times 4, which is 12 feet. And there's my length and width. Now, the next one, the triangle one. The measures of the angles of a triangle are in the extended ratio 3 to 4 to 5. So again, 3x to 4x to 5x. Now, in a triangle, the sum is 180 degrees. So I'll just add up the angles and set them equal to 180. Okay. So we get 3 and 4 is 7, and 5 is 12. 12x equals 180, and we'll divide by 12. And that'll get us 15. 15 is the multiplier that we're going to apply back to the ratio. 3 times 15 is 45 degrees. 4 times 15 is going to be 60 degrees. And 5 times 15 is going to be 75 degrees. And if you add them up, 45 and 60 is 105, and 75 is 180. Okay. Okay, next problem. This is problem 4. What we need to do is find the lengths. Find the sides. Okay, and here's this extended ratio again, 3 to 4 to 2. However, we don't need to use all 3 sides when we set up a proportion. Pick 2, and pick the one that has 8, which is going to be BC, which is the 4. So definitely pick the 4. So let's just use AB and BC, which is the 3 to 4. Okay, it doesn't really matter, but I would pick the side that has 8. So if I'm going to do AB compared to BC, okay, those are the sides I'm going to use. Well, I'm going to put the ratio as a fraction, 3 to 4, equals, and now I look at my picture. AB is this side, x plus 3. BC is this side, which is 8. And there's my proportion that I can use to find x. It is not the only one to use, but it is probably, whatever, the best one, the easiest one, I don't know. But this is one I would choose. So again, binomial, put in parentheses, 4 times x plus 3 equals 3 times 8, which is 24. Distribute. 4x plus 12 equals 24. It's now a 2-step problem. Subtract 12. 4x equals 12, and divide by 4. And x is 3. So I'm going to list my sides up here. AB is going to be 3 plus 3, which is 6. BC they gave us is 8. And AC is 3 plus 1, x plus 1, which is 4. Okay, next, number 5, we'll look at a couple special properties of proportions. Okay, so let's see if we can complete this sentence. If AB, or A over B equals 3 over 4, then B over A. So the question is, what happened? Well, the B and the A switched, right? That's how that fraction came about, B over A. They switched. So you got to do the same thing with the 4 and 3. Switch them. 4 over 3. Okay, so that's we'll call it 5a. This is 5b. 5b says, okay, if a over b equals 3 over 4, then a plus b over b. So what they did was they took a and they added the denominator. So we must take 3 and add the denominator. 3 and 4 is 7. 7, and the denominator stays the same. So just make sure you review those properties of proportions. The next problem we'll work on is geometric mean. Okay. And let's find the geometric mean between 15 and 30. Okay, these are my two numbers. All right. So remember that you can do two things. You can set up the proportion, which is 15 over x equals x over 30. Okay, so the means are the insides, the extremes, the two numbers on the outsides. And we cross multiply x squared equals, x squared equals, remember we multiply 15 and 30, but do not multiply it out. And then we'll see that we'll take the square root of both sides, and we'll get x equals the square root. And here's where we need to break down our numbers. All right. So let's see. So I know 15 is 3 and 5. And I know 30 is 3 and 10. Okay? Well, look. 2 3s. So what happens? A 3 comes out and they disappear. And I'm left with 5 and 10 on the inside. But wait. 10 can be rewritten as 2 times 5. Oh, I see 2 5s. So what's going to happen is I'm going to bring a 5 out. And when I bring it out, I multiply it with the 3. When I bring that 5 out, those 5s go away, and I'm left with a 2 inside. Last thing you need to do is multiply the numbers on the outside. 15 radical 2. Now remember, you can skip this and go straight to here. Okay, you can do that. All right, if you would like. Okay, so I believe this is number 7. Number 7, exactly what it says, find PQ. Okay, so let's take a look at this ratio and let's start filling in what we know. MN. Do I know MN? Yes. MN is 18. Do I know NO? Well, not right away, but the whole side here is 24 and MN is 18. So if I subtract, I get 6. There's NO. NO is 6. Do I know MP? Yes, I do. It's 12. Do I know PQ? Nope. PQ is going to be my X. And there we go. And we cross multiply and solve. 18x equals 72. 6 times 12 is 72. And we divide by 18. And I believe you get X is 4. So we know that PQ is 4. And again, just as a quick check, we know that 18 over 6 is the left side. Now we have 12 over 4. And divide. 3 equals 3. You're good. All right. So proportions. Okay, and last but not least, here will be our problem on similarity. Okay, this will be a very multi-step problem. So the first thing we will do is let's write the similarity statement. Okay, so we'll do multiple parts. So these two triangles are similar. So I notice that there's the right angles and that there's these angles marked with 2 markings. So that means that these angles must also be congruent. So I'll put 1 marking each. So let's write the similarity statement. Triangle, I'll start with the big one. Let's go triangle ARX, alphabetical order, is similar to triangle. Okay, A is the right angle, so N is the right angle. R has 2 markings, T has 2 markings, X has 1, M has 1. Okay, so there's the similarity statement. Okay, so now I'm going to say list the parts, which means what angles are congruent, what's the proportionality statement. All right, so just use the correspondence above. Angle A is congruent to angle N. Angle R is congruent to angle T, and angle X is congruent to angle M. There's the congruent angles. And now the proportionality statement from the sides AR over NT equals RX over TM is equal to AX, the outside ones, over NM. Okay. All right, so that's similarity statement and then listing the parts, the congruent angles and the proportionality statement. Okay, so now let's have a little bit more fun with the numbers. What is the scale factor from, and let's go from big to small. Okay, big to small, which means from triangle ARX to triangle NTM. Well, if I'm going from big to small, that means I am shrinking. So I know that my scale factor, shrink. My scale factor better be less than 1. Okay. If I look at the picture, they only give me one pair of corresponding sides. That's here. Well, if my scale factor is less than 1, the top number must be smaller than the bottom. So there we go, 10 over 15. Now you have to simplify it, though. Divide each by 5. And there's your scale factor. Okay, D. What is the perimeter, if I could spell, of triangle ARX? All right. Well, we're going to use the perimeters proportion theorem for similar polygons. All right. So we'll set up this statement: perimeter of triangle ARX over. Now we need the perimeter of the other figure. Well, they give us all three sides. 6 and 8 is 14, and 10 is 24. Equals the ratio of a pair of corresponding sides. Well, ARX we know 15 over the corresponding sides from the other triangle, which is 10. And now we cross multiply and divide. Let me scoot this down a little bit so I have some room. Cross multiply, we'll get 10p equals 15 times 24, which is going to come out to be 360. And we'll divide by 10. So the perimeter of triangle ARX is going to be 36. Okay, and then one more problem. We squeeze it on right here. E. Let's just find X real fast. All right. Well, let me look at the picture, and I'll keep scrolling up and down. X is here. It corresponds with MN, 6. That's equal to, and now we must use the common ratio, the one that we have between each figure. X started, so 15 must be on top, 10 on bottom. And we cross multiply and solve. 10 times x is 10x. 6 times 15 is 90, and we divide by 10. X is going to be 9. And there's how we use similarity and proportions to find side lengths, perimeters, scale factors, and all that stuff. Okay. All right. So thanks for watching, and we'll see you on Wednesday.